Rocket exploder. Blue Origin's New Glenn rocket explodes in massive fireball during launchpad test in Florida. A dramatic explosion rocked Florida's space coast after a Blue Origin New Glenn rocket erupted into a giant fireball during a routine engine test at Cape Canaveral Space Force Station on Thursday night. Now let's dig deeper into the story and uncover what really happened on our AI
Picture this.
podcast.
You're standing on the Florida coastline, right? It's a Thursday night.
Oh, yeah.
It's shortly after 9 p.m. The ocean breeze is blowing, and you're just looking out toward the Cape Canaveral Space Force Station.
Right, prime viewing.
Exactly. And sitting out there on the launch pad is a machine so massive it almost defies comprehension. I mean, we're talking about a 320-foot tall rocket.
It's basically a skyscraper.
Yeah, literally a 30-story skyscraper, but packed with highly combustible propellants, just waiting to fly. And you're watching a test.
Just a routine test, or so it seems.
Right. But then, in the literal blink of an eye, that 30-story skyscraper turns into this towering, terrifying inferno.
The visual is visceral.
Oh, it's why.
And, it represents the really harsh, incredibly expensive tuition that just has to be paid for progress in orbital spaceflight. I mean, we are looking at a localized explosion in Florida, sure, but the ripple effects are traveling outward in real time.
Absolutely. So we are drawing from a really fascinating report today titled The New Glenn Anomaly, Fireball at Launchpad 36.
A very detailed report, too.
It is. And our mission today for this deep dive is to go way beyond just, the fireworks of that footage you might have seen online.
Right, there's so much more to it than just the explosion.
Exactly. Okay, let's unpack this. We are going to dissect the physical anatomy of this specific anomaly, and we're going to map out exactly how this single failure creates a massive strategic bottleneck. Because it's like a high-stakes domino setup.
Yeah, that's a great way to look at it.
One piece falls wrong, one engine test goes wrong, and suddenly it threatens to topple billionaire rivalries, it delays global internet infrastructure, and incredibly, it shifts humanity's timeline for returning to the lunar surface.
It really does. Because to understand the massive scale of these resulting delays, we have to look at the engineering reality of what actually happened on that launch pad.
Right.
The event we're talking about was a hotfire test of Blue Origin's third ever built New Glenn rocket.
Okay, so let's break down the mechanics of a hot fire test for a second.
Yeah.
Because before we get to the consequences, we need to understand the anomaly itself.
Good idea.
So the rocket is rolled out to launch pad 36. It's fully fueled up with liquid oxygen and liquefied natural gas.
Right. Tons of it.
And the engines are ignited. But the vehicle is deliberately held on the ground by these massive mechanical clamps.
Yep. The hold-down clamps.
Which is wild to think about. I mean, you are commanding the engines to produce hundreds of thousands of pounds of thrust, pushing against the Earth, while the pad's infrastructure stubbornly refuses to let the rocket move even an inch.
Exactly. You are forcing the vehicle to operate in a real-world, highly dynamic environment without actually committing to liftoff.
Right.
The goal is to stress test the entire integrated system. So, you're checking the fluid dynamics of the cryogenic propellants rushing through the turbo pumps. You're testing the avionics, the vibration tolerances, the ignition sequencing.
All the plumbing.
All the plumbing and the software. And those hold-down clamps have to withstand millions of pounds of upward force, while the flame trench has to safely direct that incredibly violent exhaust away from the vehicle.
It sounds like it's like revving a sports car engine to the absolute red line while the parking brake is fully engaged, just to make sure it doesn't blow up.
That's a perfect analogy.
Except, well, this time it did blow up.
It really did. You want to see if the fuel lines freeze or if the engine block shatters under that intense internal pressure. And in this case, the system found its breaking point.
Which brings us back to that Thursday night. The timeline from the eyewitness perspective is just staggering.
It escalated so fast.
So fast. It's just past 9 p.m. The engines ignite. There's thick smoke billowing out, right?
Standard so far.
Right. Totally standard. The launch pad is brilliantly illuminated by the engine exhaust. Telemetry is flowing into the control room. And then seconds later, a violent explosion originates directly from the base of the rocket.
Right at the engine section.
Yeah. And the flames don't just stay down there or damage the engines. They rapidly race up the fuselage and engulf the entire 30-story structure.
What's fascinating here is the sheer speed of propellant deflagration. It catches people off guard.
I mean, I would be off guard.
Right, because A breach in the high-pressure fuel lines, or, say, a failure in the engine manifold that suddenly introduces liquid oxygen and natural gas to an ignition source that is outside the controlled combustion chamber.
Outside where it's supposed to be burning.
Exactly. And within a fraction of a second, this highly engineered, beautiful vehicle just becomes a bomb.
Wow.
The report notes that sparks and debris were sent flying into the night sky as the fire spread across the launch pad infrastructure.
And people definitely saw it. I mean, the towering Inferno was visible for miles along the Space Coast.
Oh, yeah, the locals definitely noticed.
Right. Emergency dispatchers in Cocoa Beach were apparently flooded with calls from startled residents because they felt the shockwave and they saw the sky light up.
Because an uncontrolled explosion on a launch pad generates a drastically different acoustic profile and pressure wave compared to a nominal, successful launch.
It sounds totally different.
Completely. But, you know, what's crucial to point out here is that the safety perimeters and the engineering protocols actually performed exactly as designed.
Thank goodness.
Yeah. Blue Origin confirmed all personnel were safely accounted for, and Brevard County emergency management officials confirmed there was no danger to the public at all.
Because everyone was cleared out.
Right. The personnel were secured in blockhouses, or they were positioned miles away at safe fallback distances. So the human safety architecture worked perfectly, even as the vehicle architecture failed.
Which is a huge relief.
Yeah.
But, okay, so the rocket is completely gone.
Vaporized, basically.
Yeah. But rockets are fundamentally just, metal, composite materials, and plumbing.
They're built on assembly lines.
Right, they can be replaced.
Yeah.
But reading through the source material, the true casualty here isn't just the New Glenn vehicle itself.
Not at all.
The catastrophic loss is the surrounding architecture of Launchpad 36.
Yes. The destruction of the actual launch facility creates a hard stop for the entire program.
Let's talk about why that is so devastating. First, let's look at the immediate payload that was supposed to fly on this specific rocket.
The Project Kuiper satellites.
Right. This vehicle was scheduled to launch 48 Amazon Project Kuiper broadband satellites into low Earth orbit. And the FAA had targeted a launch window opening as early as June 4th for this.
And now that payload is just sitting in a clean room with nowhere to go.
Exactly. And Project Kuiper, just for some context, is Amazon's initiative to build this massive constellation of satellites to provide global broadband internet.
Right, to compete with Starlink.
Exactly. But low Earth orbit constellations require a massive number of satellites working in tandem, right?
Yeah.
You need continuous coverage.
You can't just launch one or two, you need hundreds, and they have to be spaced out perfectly.
Right.
And to build that geometry in space, you need a high-frequency, super reliable launch cadence.
Okay, but wait, I have to challenge the severity of this bottleneck for a second.
Okay, go for it.
Blue Origin has the financial backing of Jeff Bezos. He's literally one of the wealthiest people on the planet.
Very true.
So if the launch pad is damaged, surely they have the capital to just, run cruise 24/7 and pour a new concrete pad in a matter of weeks, right? Why are industry experts in the report claiming this repair process could take several months and cripple their ability to compete with SpaceX?
That's a totally fair question. But if we connect this to the bigger picture, concrete is actually the cheapest and easiest part of a launch pad.
Really?
Oh, yeah. A modern orbital launch pad is a highly complex machine in its own right. It's totally interwoven with sensitive, custom-built systems. Let's take the Deluge water system, for example.
Okay.
When a heavy lift rocket ignites, the acoustic energy, just the sheer volume of the sound waves, is violently powerful. If that sound bounces off the concrete pad and hits the rocket, the vibration will literally shake the vehicle to pieces.
Oh, wow. So to prevent the rocket from vibrating apart, they flood the pad with water.
Exactly. Hundreds of thousands of gallons of water in seconds, just to dampen that acoustic energy.
That's insane.
It is. So if the pad blows up, you have to rebuild those massive high-pressure water lines and the storage tanks that deliver that deluge.
Right.
And then you have the cryogenic systems. The pad is routing liquid oxygen at minus 297 degrees Fahrenheit.
Minus 297.
Yeah. The plumbing for that requires specialized metallurgy and insulation. It has to expand and contract without fracturing under immense thermal shock.
That sounds like a nightmare to fix.
It is. Rebuilding and recertifying high-pressure, sub-zero fueling lines, all the avionics connections, the structural hold-down clamps that takes months of meticulous engineering. Honestly, regardless of how much money you throw at it.
You can't just rush physics.
Exactly.
And here's the real kicker. Launchpad 36 is Blue Origin's only operational launch pad for the New Glenn rocket.
Their single point of failure.
Right. If this were SpaceX, they have multiple pads in Florida, Texas, California. If one pad goes down, they just reroute the payload to another facility.
Seamlessly.
But because Blue Origin has this single point of failure on the ground, their launch cadence is suddenly reduced to 0.
Yeah, 0.
Every month spent clearing debris and rebuilding that cryogenic plumbing is a month. SpaceX operates and dominates the commercial market without its primary heavy lift competitor.
Because the commercial space race is measured entirely by launch cadence. Infrastructure redundancy is just as critical as vehicle redundancy.
Absolutely.
But, the implications of this damaged pad extend way beyond commercial internet satellites in low Earth orbit.
Oh, absolutely they do.
Yeah.
The shockwaves of this Thursday night explosion, they actually extend 238,000 miles away. All the way to the moon.
Right into NASA's lab.
Exactly.
Yeah.
It directly impacts NASA's Artemis program. And for those listening, Artemis is the massive initiative to return humans to the lunar surface.
It's a big return.
Right. And Blue Origin is one of only 2 companies selected by NASA to develop the lunar landing systems, the actual vehicles that will ferry astronauts from lunar orbit down to the surface of the moon.
And NASA deliberately chose both SpaceX and Blue Origin to build these landers for a very specific reason.
Redundancy.
Exactly. Because spaceflight is inherently risky. The procurement strategy was designed around redundancy. If one contractor faces a severe developmental delay or, say, an anomaly on the pad, the other contractor can keep the national timeline on track.
Right, but the falling dominoes from Launchpad 36 hit some very specific, very upcoming Artemis milestones.
They sure do.
First is the Artemis III mission. The flight plan there requires astronauts to practice complex docking maneuvers with lunar landers developed by both Blue Origin and SpaceX while they're up in orbit.
Right.
But if the New Glenn rocket is grounded, Blue Origin's lander cannot reach orbit, which puts that dual docking practice completely in jeopardy.
And beyond that, you also cannot put humans in a lander until you have proven the vehicle's safety through robotic testing first.
Right, obviously.
So Blue Origin was scheduled to launch a robotic precursor mission called the Blue Moon Mark I lander later this year.
But that robotic lander requires a New Glenn rocket to escape Earth's gravity well.
Exactly.
So without Launchpad 36, the Blue Moon Mark I test flight is grounded. The entire sequence of lunar qualification is basically paused.
And the timing of this anomaly really highlights the volatile nature of aerospace contracting.
It's kind of ironic, honestly.
Very, because just days before this explosion, NASA actually awarded new contracts to Blue Origin to deliver uncrewed lunar rovers to the moon for the Artemis IV and Artemis V missions, which are scheduled for later this decade.
Just days before. I mean, it's like finding out your lead contractor accidentally burned down their only workshop, just days after you signed a massive contract to have them build your house.
That is exactly what it feels like. But the reaction from NASA Administrator Jared Isaacman in the report is really telling.
Yeah, he didn't panic.
No, he didn't issue threats about pulling contracts or express panic at all. He just stated that spaceflight remains extremely difficult and unforgiving.
Which is very true.
Right. And he confirmed NASA would work closely with Blue Origin during the failure investigation.
Which makes sense. I mean, they need them.
Yes. Isaacman's reaction reflects the maturity of modern space procurement. NASA is not running away from Blue Origin because they engineered this exact type of catastrophic delay into their strategy from the start.
They knew it could happen.
They know that pushing the boundaries of thermodynamics and material science results in hardware loss. It's inevitable.
Yeah.
NASA needs multiple commercial partners. Investigating this failure alongside Blue Origin ensures the data gathered will make the next iteration of the rocket and the next launch pad design much safer for the eventual crewed missions.
Which brings us to the human reaction from the top. From Jeff Bezos.
Yes.
He took to social media and acknowledged it was a, quote, very rough day for the company.
An understatement.
Right. And he frankly admitted it was too early to determine the exact mechanical cause of the failure. But his concluding thought really encapsulates the whole ethos of developing heavy lift systems. He just wrote, "It's worth it."
And he's right, because you cannot build a reliable heavy-lift orbital rocket without finding out exactly where its breaking points are.
You have to push it to the limit.
Exactly. Failure isn't just a possibility in this industry, it is an absolute prerequisite.
Here's where it gets really interesting, though. This is ultimately a story about the aggressive acquisition of data.
Yes, the data is gold.
When engineers are attempting to control the violent release of millions of pounds of thrust, explosive failures are not the end of the road. They are just incredibly loud, incredibly expensive data points.
Well said.
Because in the milliseconds before and during the explosion, the rocket's telemetry systems were broadcasting millions of data points back to the control room.
Telemetry is the lifeblood of aerospace engineering.
Right.
Sensors throughout the vehicle are constantly measuring pressure spikes in the turbopumps, temperature fluctuations in the cryogenic tanks, and those micro vibrations in the hold-down clamps we talked about.
So they see everything.
Everything. Even as the rocket was tearing itself apart, it was transmitting the exact sequence of components failing.
Wow.
And that data will dictate the redesign of the fuel manifolds, the engine cooling jackets, and the automated abort software for the next build.
So sure, the third New Glenn rocket was sacrificed on the pad, but the fourth New Glenn rocket will be fundamentally safer because of the telemetry gathered during that destruction.
Exactly. The mission to low Earth orbit and the moon remains unchanged, right? It's really only the timeline that has shifted while the infrastructure is rebuilt.
And the entire industry watches these anomalies closely, don't they?
Oh, absolutely. The data informs not just Blue Origin, but the collective understanding of orbital mechanics and vehicle stress limits across the board. Every competitor learns something.
Okay, so as we wrap up this deep dive, there's a final thought to consider for everyone listening, something that really builds on the vulnerabilities exposed by this whole event.
Okay.
We've seen that a single plumbing failure or an engine anomaly didn't just destroy a replaceable vehicle, right?
Right. It did much more than that.
It crippled Blue Origin's only operational launch pad for months, creating this devastating bottleneck.
A huge strategic setback.
Exactly. So, here is the provocative question to mull over. Will this catastrophic bottleneck force a fundamental rethinking of how private space companies sequence their testing and build their facilities?
That's the big question.
Because if a rocket blows up, you lose a single vehicle and maybe a few weeks of manufacturing time. But if a launch pad blows up, you lose a year of your launch cadence and you surrender your market share.
Yep.
So, does the immense cost and extreme vulnerability of ground infrastructure now pose an even greater risk to the timeline of humanity's return to the moon than the rockets themselves?
It absolutely forces an evaluation of capital allocation. I mean, companies must decide if the immense upfront cost of building a redundant secondary launch pad is now just a mandatory requirement before conducting hazardous hot fire tests on their primary pad.
You almost have to have a spare pad just in case.
Exactly.
It completely changes how you look at the complexities of space travel. The road to the stars isn't just about the cool vehicles we build. It's about the fragile, earthbound infrastructure that throws them into the sky.
Very true.
Keep asking questions, keep looking up, and we'll catch you on the next deep dive.
Okay, one question for you. If Blue Origin faces long delays after this disaster, could SpaceX gain an even bigger advantage in NASA missions, commercial satellite launchers, and the future race to dominate the moon and deep space exploration? Don't forget to comment it. Thanks.